You might recall, if you stayed awake that long, that we went over triangles in class on Friday. And we specifically used SO, CA, TOA, this sine, cosine, tangent, relating the proportion of the sides to the angle that we're looking at itself. We've also talked a fair amount about a squared plus b squared equals c squared, and we've used that to solve for any of these pieces that we need. One thing I don't think I've emphasized enough is that these pieces only apply to right triangles. If you have a right triangle, go ahead and use any of these. If you don't, we need to use what is actually the complete equation that goes with Pythagorean. And that's part of the equation sheet that I gave you on Friday. These little pieces here are what we have to use when we don't have a right triangle. The reason why you don't need these and why everybody knows this piece is because at cosine of 90, this goes to 0, so we only need those pieces to begin with. But when we move out of the world of right triangles, life gets a little bit more complicated, but not so much so that we can't do it. So let's look at an example. I have a 5, 7, 8 triangle. The first thing I do is make sure that I'm keeping track of what side and what angles I have. So I label everything. I'll call this guy C, and that means this angle is big C. I'll call this guy B, means this opposite side will be little b. And I'll call this guy A, which means this little guy will be A. So let's start off by solving for B. Come over here. It's kind of handy by labeling them the way I have. I want to solve for B. So if I solve for B, I need to use this equation. That will give me this angle B. So let's look at that. We have B squared equals A squared plus C squared minus 2AC cosine of B. Groovy, except for we want only that angle. So let's start this off by developing a habit of solving this equation for what we want, so in the end we just button push and we're there. I'm going to start with addition of subtraction. It's just cleaner for me to see it that way. Subtract my A and C from that side. That means I need to subtract my A squared and C squared from this side. So let me rewrite that. I now have B squared minus A squared minus C squared equals negative 2AC cosine of my angle B. Now I want to make this piece go away. So I'm going to divide by negative 2AC and divide it by negative 2AC. Now, for me, this is cumbersome. There's a step you can do in your head, but if you're not comfortable with it, I would suggest not doing it in your head to begin with. Is I'm going to multiply to get rid of, sorry, wrong terms. I'm going to distribute my negative to just make it cleaner so I'm not worrying about that negative in the end. By distributing it, it's the same as going negative 1 times all of these pieces. So I end up with A squared plus C squared minus B squared divided by 2AC. If you don't want to do that step and you just want to key in your negative, feel free to do that. So now we need to get rid of that angle. Now remember, to get just this inside part out of this function, I need to take the arc cosine of B, because these two things times each other give me just my B out. But I've done it to this side, so now I need to do it to this side. Make sure you can see that. Okay, let's rewrite it so it's cleaner. I now have B equals the arc cosine of A squared plus C squared minus B squared divided by 2AC. Cool. Let's go ahead and put our numbers in now. Equals cosine, and because I've labeled things, it'll be easy for me to keep track. So a is 5 squared, and c is 8 squared, minus b is 7 squared, divided by 2 times 5 is my a, and my c is my 8. And close my parentheses. And I'm going to put that in my calculator and see what happens. And after some button pushing, I come up with, I am going to be taking the arc cosine, I don't know if you can see that, of 80. I'm sorry, of 1/2. Okay, so once again, my arc cosine on my calculator has this green shade to it. So I want to push the green button, hold it, and push the arc cosine button, and then key in what it is, whatever the ratio is I want to solve for. So in this case, 0.5. Hit enter and I get B equals 60 degrees, which indeed it does. Phew, we did it right. If you have any questions, go ahead and post them, and we are going to move on from this. You have a similar problem in your homework this week that deals with being able to solve triangles. The only other little piece in there is just a reminder that the sum of all triangle angles equals 180. So if I add up all of my interior angles, they all come out to 180. Just in case you have let that little tidbit of information leave your head, there you have it.